Matter of fact, I'm gonna go ahead and do this real quick. Let's kind of configure my snippets real quick. Let me see this here. We're gonna fix our snippets real quick. So devlog should be title and then daytime. That's fine, but we want it to include a line for the staging, committing, and push changes, because we do that every single time. So we just want to add that to the snippet there. So I don't have to write this out anymore. It will already happen. And as a matter of fact, we're not gonna worry about minutes as far as what we did. Like in each little task, we're just gonna keep track of the time overall, you know. So yeah, I think that will do. So now let's go over here, and now when we do our snippet, which is Control Alt slash forward slash whatever slash that is, we do devlog here. There we go. Now it automatically takes care of adding that section. So it's 11 o'clock on the dot. Look at that. And like I said, we're not going to keep track of the minutes. We're going to keep track of just the overall session and what we did during it. It doesn't really matter if we spent 20 minutes on this, 2 minutes on this. It's just, that's irrelevant, right? Continue working on code which will reconnect the client to the proper gaming that worked in. And this is going to be a question mark. And the title here is going to be the same, except it's just part 17. We're still working on this same section. You see how much better that looks? It's just cleaner, you know. Well, actually, how about this? We will modify the snippet just a little bit further. Control Shift P. Let's go to that snippets, and we're gonna fix it a little bit further by having the we'll do like this. This. Copy these three. Well, we don't need to do all that. Let's get it right here. Do it like such. Paste that in. And I don't know why. I guess this is just how we have to do it. And then we should go 1, 2, 3, 4 for indent. So this is going to be overall summary. And then this is going to be specific task list. And then we will have that. Yeah, that's better. So now whenever we do a devlog, we'll just do it like this, bam, and then all we have to do is fill in the title, the date here, and then the time. Then we have our overall summary, specific task list, and we don't have to write this anymore. So it should just make that a little quicker, because it was becoming kind of slow. Alright, so I tweaked my back, man. I have back issues, and man, I swear, tweaked it pretty bad. It's not great, if I'm honest. So let's go ahead. We need to set our timer. check the stream, see if it's actually working. Check the sounds like the audio is working pretty good. So we can close that out. Post this. Turn that volume back down. Make sure it's still running. Okay, it is. Alright, so let's see. Our timer needs to be set. Let's check that out. We got 5 minutes, so we're gonna do what, 60? It's going on 6, so we'll do 62 minutes. And alright, timer is set to 62. And let's see, what do we have? Alright, so yesterday, what did we do? We did an hour and a half. We continued working on code for reconnect. We reviewed code, modified server and network receive, which handles receiving and parsing the header string to check against the string X instead of checking against 0 through 9 to improve performance. A very minor alteration. Converted the aforementioned header string parsing code into a function called parse receive header. Since it's used 2 times in server. Continued implementation of code in server which receives the client token from the client side for authentication. Okay, and then we stopped at line 725. So let's... Well, and I guess, you know, we should... I guess I like it better having the stage commit pushed inside of that... What is happening here when I'm doing this? Like, what is... What is the... What is happening? Oh, it's Control Shift P. I was doing Control Alt P. But the question is... Oh, that's bookmarks? I thought it was Control Alt N. Oh, it's Control Alt N and then Control Alt P. Next and previous. Okay, so that's... I was hitting that wrong. It's Control Shift P for the command palette. So we're gonna do one last change. Put that right... Well, I don't know if that's gonna work actually. Let's do 1, 2, 3, 4. I don't know exactly how these snippets, like syntax, snippets file syntax is supposed to work, but I know it's... I think it's a little different than regular files. What is a regular file? Alright, so yeah, we're picking up here. That's where we left off yesterday. So here at the top we have this need to reassign self-con, self-other-con to refer to the new con object. And that's where we stopped. So I guess we'll go ahead and take care of that real quick. Just need to reassign self-con, other-con for the new con object. And let's check if this is in things to do. Reset. Yep, that is the #1 task. Be careful, thoroughly review. Okay, so we checked our notes for that task and looks pretty straightforward. So let's look up self-con here. Actually, we don't need to do a project search. We'll just do self.con like this. Okay, so there's actually no such thing as self-con. It's self-con 1 and self-con 2. So this threaded client will have access to client num. So technically, right, I could just use client num to recheck it again, right? I mean, that seems like the way to do it. And other con hasn't been changed at that point, so there's no reason to modify that. Alright. So really what we need to reassign is self dot, well, we don't know if it's con1 or con2. So we'll just say con1/2, and then we don't have to reassign other con because it has nothing to do with other con. The other client would technically have to, or the other thread rather, the other client thread would have to update its other con though, wouldn't it? But we can't actually cause the other thread to do that. The other thread would have to do that itself. So how do we get the other thread to change it's like to change that? Because well, wait a second here. Is that how this works? Yeah, so we have the server side main process spawns a child process. Each child process has 2 threads, or 3 threads rather, the main thread, and then the 2 client threads. This instance that we're working from, or in the context rather that we're working within here, is in the threaded client function, which is in the context of one client thread. So this will each threaded client has a con and then an other con namespace. So I see how we could fix this, I think, because currently we initially assign con and other con to each respective connection socket object. So at the beginning of the threaded client, con here, if this is client 1, would refer to client 1's socket connection, and then we have other con would refer to client 2's socket connection. So from the perspective I'm getting confused about this though, because if you share the same namespace, like you have one thread and this thread calls its connection con, and then the other thread calls its connection con. I mean, I'm quite certain that works, but I'm forgetting how does that work, because they share the resources. I'm having a brain fart with this, because that's the whole point of having locks, right? Is if we have a competition between threads for the same object. But these are not the same memory address objects. These are just the same namespaces. So we wouldn't need a lock. Yeah, so there's nothing wrong with it as far as like the way that it executes in the namespace. We can have a con namespace in 2 different threads referring to 2 different socket objects, and there's no issue with that. They differentiate between that. Even though they're shared memory, it's like 2 different locations in memory just being referred to by the same namespace but in 2 threads. Anyway, so I think I've remembered how that works again. But we still do need that other thread to understand that we're now dealing with a new connection, so that it can send data to that other client through the other con namespace. Because currently, without reassigning other con in the other thread, it would refer to that old connection that doesn't exist anymore. So what we would need to do is we would have to like I'm trying to think, couldn't we use a mutable object and like change the index? Like, couldn't we make other con refer to con list at index 0, and then whenever we updated con list, it would update? But that's not how it works, actually, because it gets assigned like once, basically. When you say other con equals con list at index 0, unless that gets rerun, it's gonna still refer to that old index object memory space, even if you subsequently update the now what we could do is what I think I was on the edge of thinking about is if we directly like accessed it through con list. So if instead of, but then we would have to that wouldn't work either, right? Because if we did con list at index 0 instead of using the namespace con, that wouldn't update it. Like, that means we'd have two threads referencing the same mutable object, and we couldn't access the same index and then be two different objects. It would be referencing the same connection object. I'm trying to think a clever way to do this without having to like make the other client thread like trigger it, you know what I mean? I was trying to think of a clever way to have it happen from this thread without having to like use a Boolean switch, and then the other thread checks for the Boolean, and then if the Boolean switch is true, then you would update the con or whatever, the other con namespace to the new connection. But we might have to just do it that way. Let's see here. So firstly, though, before we forget, let's add this. We'll say also need to ensure other thread refers to other con refers to, or let's say reassigns other con to this new con object. Yes, that's true. So firstly, we'll make these two separate things. Here. I'm gonna put also like this, and I know all this stuff is extra, but this is really the way to do it, guys. All right, so this is gonna say if client num, because this is in the context, yeah, so we have access to client num. So if client num is equal to 1, then self.con1 equals con, right? Isn't that how we do it? Just make sure. If con1 equals none. Self con1, self adder 1. I don't know if we necessarily need the address. Yeah, so we say con equals self con1, and we previously assigned con1 here. So we don't explicitly say self con1 equals, we use self con1 comma self adder 1. So con1 equals con adder, and yeah, and that is if the, hold up here, if connects num is equal to 1. Yeah, we were supposed to update this to refer to like client num instead of connects num and stuff. I remember, but the point is here, connection 1 is associated with client 1. I just wanted to verify that before I assumed it. Yeah, if self adder 1, and previously we would use the address, the IP address, to check for this, but we won't use that anymore because we know that changes. So self con 1 does, if adder 0 is equal to self adder 1. Yeah. And then yeah, if client 2 is online, we know that the one that disconnected and is reconnecting is client 1, therefore we refer to it as client 1, con 1. And I know this sounds confusing. That preliminary section is confusing. It's actually going to go away because it's dumb, and well, it's not. It was extra, and we don't actually need that anymore. So here's what we do. Now we're going to do, if client num is equal to 1, self con1 equals con, and we don't even necessarily need this attribute. I think the only reason that we save it as an attribute is like something to do with the save system. We wanted to implement a save system on the server side as well, but it's, you know, that's neither here nor there. So we're done with that. So now if client num is equal to 1, self con1 is equal to con, and then we say else, which is the same as saying elif client num is equal to 2. Self.con2 is equal to con. And we can't say other con because we need that executed from the other thread. The other thread has to do that. So we'll get rid of this. We will put a little div here. I like to keep my stuff segregated there. And this is going to be, oops. I got to go back and copy this again because I messed up. So let's copy that, redo it, and paste that in. This should be below section 731. Reassigns self-con1 to refer to the new con object. Yep. Alright, so we say if we see con equals self reconnect socket dot accept at index 0, and then if client num is equal to 1, which was passed to threaded client, which is correct. So if it's equal to 1, then we say self con 1 is equal to con, and then else, which is the same as saying elif client num is equal to 2, so that's the only other thing it could be. Self con 2 is equal to con. Alright, so that's good. Now what do we do here? So we have to need to ensure the other thread reassigns other con to this new con object. So how do we accomplish this? That's the question. Let's see. We're going to go over to ChatGPT real quick. And let's go to, we'll just create a new one. We'll say Python 3 multi-threading online game. And we paste this in. And need to ensure other thread reassigns other con to this new con object. Is there a clever way to reassign other con namespace associated object that exists in the other thread via this thread? Objects live in a shared memory. Technically, you can reassign other con from one thread if you have access to it, but you have to do it safely. If each thread is running its own handle client con or similar function, other con is a local variable inside that thread's scope. You cannot access it directly unless you share it explicitly via some shared structure. Cleanest way, use a shared mutable object like a dict or a list with a thread safe access. So we'd have a dictionary, client 1, client 2. So shared player key equals con. So if we did that and we updated the player key, the key value pair at that particular key, the other client would still understand the other con namespace to refer to the old connection. That wouldn't actually fix our problem. But if the other thread, if both threads use other con namespace to refer to each respective con that is not their thread's con as other con, this dict wouldn't solve problem since other con still refers to old con. You have two threads. You do look at very card other con. You want to reassign the other thread's other con from this thread when a new connection is created or swapped. Would Python can directly reassign other threads local variables. Each thread's other con is local to that function call stack and not visible outside that thread. You can rebind another thread's local variable from here. You could use a shared wrapper object that both threads reference. Instead of using other con as a primitive local variable, like def thread 1 con, is local isolated, you can do class conref. Conref, what the fuck is this weird ass solution? Thread 1 uses myref con. And then if you reassigned, yeah, if you reassigned myrefcon if other con uses. Now if thread 1 wants to reassign thread 2's other con, it's actually modifying player 1 con, which thread 2 is referencing live. Oh, I know what I could do. Okay, so I could use the dict thing. I would just have to make sure that before we handled other con, we would update the other con through that dictionary. So we could have a condict, and then we would just have to, before we referenced other con, we would ensure that the other con gets changed. You know what I mean? Does that make sense? And that's fine, but that would like check it every single time, you know, or that might reassign it every single time, when in fact so this is for reconnect and then start main while loop. Let's see here with other con lock, so it's just right there. That's the only place. 11. No, it's not the only place. It's just 2 places. But this while loop happens over and over and over and over again. So any little like performance hindering action is going to be multiplied like times 1,000, you know, because this is just a while loop over and over again. That's the entire game. So I would rather not reassign other con every single time. Does that make sense? I would rather just do whenever, like, we just do it one time, aka we're not gonna use that dictionary. What we're gonna do instead is use like a triggering event. So we're basically gonna use a shared boolean. So we'll say self, and this will be inter thread. This will be shared threaded, a shared object. So you would need a lock, right? Yeah. So it'd say with self dot, what are we gonna call this? Well, yeah, so since this is shared, we don't have to have the lock to be, well, they don't have to be shared. So we'll have to use some lock. We'll say, well, not if it's not shared. If it's not a shared object, well, yeah, it's gotta be shared because there has to be a connection point, and the boolean would be the connection. So we would say other con, and I know this is going to be complicated wording, but that's just the way it is. So if client name would say self-con, and then we would do, well, we can actually, we're going to have to put this up here in this section, right? It's going to have to be included in this section, because it's going to depend on whether we're client 1 or client 2, right? So then we would say with, we say self dot con 1 other con change. Let's say let's do it like this. Con 1 change other con bool, or change other con lock. So with self dot con 1 change other con lock, we'll say changed other con lock. So with that lock, we would then trigger this boolean. Well, technically, like, we could just using a boolean is faster performance wise, but we could, with less code, we could just create a prior other con, and like we could say prior con 1 other con, and then we would just compare that con to the new con. You know what I'm saying? But that might be like a good bit of overhead, and I think like the performative option, like the proper, option would be to use a boolean. So instead we'll say, so we're going to use a shared boolean because that's like lightning fast. It's just checking against 0 or 1. So with that lock, we'll say self.con1 changed other con bool equals true. That means we'll say other thread checks this shared bool to see if they need to reassign other con prior to handling it. And then we need to have this, we'll say ensure that this boolean gets reset back to false after other thread reassigns the other con. Okay. And then here, for if client num is equal to 2, do it like this. So we say self_con2 equals con. With self_con2 changed other con lock. Self.con2 changed other con bool equals true. So this is a shared boolean between the threads, and this is a shared boolean between the threads. This each respective thread will set this boolean at this point in time, while the other thread may also be checking the boolean at the same time. So we have to use a lock, and that means that the lock is also shared, right? Yeah, like locks are shared objects. Obviously we don't have to lock the lock because it's self-explanatory. So yeah, I think this is correct here. If client num is equal to 1, self_con1 is equal to con. With self_con1 changed other con lock, we need to create this variable, or whatever we call this. So to do create the below, create this adder. And then we need to create the other adder as well. It's so much comments, dude. Coding is, at least in my opinion, if you're doing it right, is like 60% comments. It's more than anything. Okay, so ensure this language is back to false. You create that adder, and we also have to create these adders, and we can do something clever here. We can duplicate our cursor, so we'll do control click. Then we have two cursors. No, that's not right. It's alt click. There we go. Now we have two cursors, and then we'll say create these adders, and it's going to be self con1 changed other lock, and then it's going to be self dot con1 changed other con bool. And can we have two? No, I don't think that would work. This needs to be changed to 2. And this one needs to be changed to 2. Alright. Below 2 lines, create these adders, self con1 changed other con locked, other con lock, con1 changed other con lock, con1 changed other con bool, and so we say with self con1 changed other con lock, self con1 changed other con bool equals true. Okay. Should be below 1. Okay, now we have con2 equals con. Below 2 lines, create these adders. Con2 change other con locked. Con2 change other con bool with self. Con2 change other con lock. Right. Ensure that this boolean gets reset back to false. Change other con self. Con2 change other con bool is equal to true. Okay, so that's correct. Other thread checks this third shared bool to see if they need to reassign other con prior to handling it. Alright. And we also need to reassign this self con1 or con object using locks and associated shared bools. And we also need to add the code which checks it. So here. Add code in all places in server pi, can't type at all, that access modify other con Code in all places in server by the access modify other con. 2. Check the con bool prior to handling other con. Right. Add code. All places that access modify other con. And all places in server prime. That access modify other con. To ensure this boolean gets reset back to false after the third reassigns other con. True. Okay. Type bool. Purpose: the boolean shared among threads which gets set to true whenever a thread changes their con object upon reconnection. After DC, since it's a new con object, triggers. The boolean shared among threads which gets set to true whenever a thread changes their con object upon reconnection. After DC, since it's a new con object, triggers the other thread to reassign its other con namespace to refer to the new con object. Is reset back to false after other con is reassigned. Self.con1 change other con bool equals false. Con1 change other con. Well, actually, shouldn't this just say con1 changed con? Yeah, that's what it should be. It should be called con1 changed other, or you just say con. So we'll copy that. It should be changed to con1 changed con bool. So it's not actually changes. It's not actually changing the other con. It's changing the con. This is the most confusing, hardest, some of the hardest programming I do. It's right here. Con1 changed con bool. Change con bool. Okay. And now this is going to be changed to con2. This is going to be changed to con2. So we have con2 changed con bool. And make sure there's no extra space at the end. Con2 change con bool. And then we have to find con1 change other con lock. We'll copy this. And it'll be con2 change con lock. Yeah, check right there to ensure no extra spaces. So we have here con1 changed con lock. Con1 changed con lock. And now this will be con2. This will be con2 change con lock. So let's go back up here. Con1 change con bool. Con2 change con bool. Con1 change con lock. Con2 change con lock. Yeah, it gets a little confusing a little bit when you're like 1 2 1 2. So we go back up here. So we have if client num is equal to 1, self con1 equals con1 change con lock with self con1 change con lock. Con1 change con bool equals true. Else, if client number is 2, con2 equals con2 change con lock, con2 change con bool. Right? So we created those adders. That's done. Alright, now we have to add code and all places in server that access modify other con to check if one changed. And this should just be a changed con bool. So what do I like to ensure to check it? Self con1 con 2 change con bool prior to handling other con. Alright, so then we'll do other con. And not in the preliminary section, but in the not there. Is this in the main while loop? Up here, check one more time. So this is in preliminary section. there we have main while loop starts here. So from here onward. Alright, so right here we need to do with other con lock, other con send all. So first we need to say with, well, I actually need to check if client num is equal to 1, then this needs to be so with, and then the custom logger, same indent. So we go right here. So if client num is equal to 1, then with self dot no, actually we'd say if self dot con 1 change con bool is equal to true if other thread changed con object upon reconnect, upon successful reconnect. So yeah, if it's client 1, well, actually if client num is equal to 1, then we need to check if con 2 change their client, because this is client 1, so then the other one is going to be client 2. So if con 2 changed their con, right? Let's see here. So if we're con 2, then we said our con 2 changed, yeah. And then if it's client 1, you reference the other client. So if you're client 1, you check to see if con 2 change con bool is equal to true. If it is, then you need to first we need the lock to check that variable, because that is a shared object. So then we would say with self dot con 2 changed con lock, if self dot con 2 change con bool is equal to true, then you need to say other con equals self dot con 2, right? Yeah. So if you're client number 1, you want to check if the con 2 has changed their connection. So you use the con 2 change con lock to check, because that is a shared object, so you have to use the con 2 change con lock to check if con 2 change con bool is equal to true. If it is, then you need to use other con lock as well, because you're reassigning other con and you're using self con 2, and con 2 is a shared object, so then you have to use another lock. So then you would say with other con lock, you would have to use other con equals self dot con 2, right? Yeah, so if client num is equal to 1, and we need a div here because that's a lot of work, we want to make sure this gets reviewed as well. So if client num is equal to 1, with self con 2 change con lock, because if you're operating from the threaded client number 1, you would use the shared con2 change con lock object, because that is what thread number 2 would use when it changed the con2 change con bool. So you would use that lock, so it is a shared object. We would then check to see if self con2 change con bool is equal to true, which means if the other thread changed the con object upon successful reconnect. And then with the other con lock, because we're handling other con at this point, and that is a shared object, which technically the shared object would be con2, not other con, but nonetheless we would still use the other con lock, and we would say other con equals self dot con2, because we have reassigned con2 to equal equals the new con. Yeah. So we do self con2 equals con, then we use con2 change con lock to set the con2 change con bool equal to true. And then now we go back up here to this code with other con lock. So other con equals self dot con2, and then we have to set the self con2 change con bool back to false in the context of the lock. Right? Resets bool back to false. Yeah, I mean that's pretty self-explanatory. So now we have others assigned the other con to self con2. Self con2 change con bool is equal to, or that's not right, not equal to, just equals. And then that should take care of that. So final review: if client num is equal to 1 with self con2 change con lock, if self con2 change con bool is equal to true, we have to use the lock there. Then with the other con lock, if it is equal to true, we would say with other con lock, change the other con equal to self dot con2, and then we would say self, and this might be a lock issue, right? Because well, no, I don't think it would be actually. I was thinking we might have a deadlock issue there. Other con equals self con2, and then con2 change con bool equals false. So set that back, because con2 has no longer changed their con. That's over with. Yeah, and that has to be reset. And now we have other con referencing the new connection properly. And then we would just do the same thing, but for the case where client num was equal to 2, we would just duplicate this code here, and then we would say if you're operating from client 2, then we want to check if client 1 changed their con using the con1 change con lock. If con1 change con bool was equal to true, then with the other con lock, we would say other con equals self con1, and then we would reset the con1 changed con bool back to false. Yeah, there we go. So now this section here, 731 5, we can just say created checks to see if other thread has changed their con object upon successful bool reconnect. If so, reassigns other con to reference that new con object using the proper shared bool and lock. Yep. All right. And then, so now we have the other con is set to the new connection, and then we do handle other con again. So we may want to put this inside of a function, since this is going to be duplicate code. Since this code is duplicate, C lines number, then can we put it inside of a function? Alright, and then the other place, so we're just going to copy this entire section here, and then we're going to do other con. See where else. So we go all the way back to 1 here. Let me keep going. So this is the preliminary section. Then we have the starting of the main while loop. So this is here in threaded client. So that's the section we just created. And then we check the other con. So prior to accessing the other con, we will check to see if it needs to be reassigned. And that would be a rather fast operation. It's checking int against int. Then it's using a lock to check a bool. And it only runs this, so this should take like 1, 2, 3 microseconds, nanoseconds. It should be extraordinarily fast. Instead of updating other con every single time, which would probably take like 10 nanoseconds or something like that, it would probably be way slower. So then we want to do it again. Next time we use other con, which is right there. Yeah, so we would go back all the way up to here to other con lock, right here. So let's add this section, and this is in threaded client. This is just the, this is another place where, like, what section is this? This is for, what is this for? This is if it's a resend request. So sometimes we have a resend request. Okay, and this is a standard request. This is a non-resend. This is an initial send request, not a request, but an initial send. So we would have this exist at this level here. So we have pre-serialized data, data pickle dumps, message head. So we create the message to be sent. We then check client num. And this is in the context of threaded client. Then we would do the same exact thing with con2 change con lock. If sub2 change con bool is equal to true with other con lock, other con equals con2. Then we would reset the bool back to false, else if client num is equal to 2 with con1 change con lock, if that change con bool is equal to true with other con lock, other con equals self con1. And then we would reset it back. Yeah, and then we would say with other con lock, other con send all. See, so what we could do is we could just reassign other con to equal the new connection. That would be a way to do it. And I wonder if just doing that would have been faster. if we could have just said with other con lock, other con equals con 1 or con 2. I wonder if that would have been faster. Because we are potentially, well, we're still dealing with the lock here, but I don't know. I don't know like how fast that would be. I feel like honestly that would be faster probably if we just did it the other way, where we would just say with other con lock, other con equals self.con 1 or con 2, and then whenever we reconnected we would just reassign con 1 or con 2 to the new con, and then they would just reassign it every time. So I wonder what's faster. I feel like maybe just the reassignment would be faster. And then versus with other con lock. We say with other con lock, and prior to that we would just do other con equals, well, let's see, if client num is equal to 1, then other con equals self.con 1, and then else other con equals self.con 2. Or rather, if client num is equal to 1, then the other con would be equal to con 2, and then if the client num was 2, other con would be equal to 1. So this is to be copied here, and then we're testing this code here. It's just test code, it's not real. And I don't know why I did it like that. So now let's compare. So we're gonna overwrite this here. So right up to here. What the fuck did I do? Alright, now we have this with other con lock. If client num is equal to 1, other con equals self con 2, else other con 2. And then we're gonna say, well, we don't care about the data being sent part, so we can remove that. We'll say which one of these two options is faster using time it. If you're comparing two ways of assigning other con from shared data across threads, you want to know which is faster using time it. The second version of direct assignment under a single other con lock is faster than the first, which checks a flag and acquires 2 locks. Double lock with flag. Check a flag, other con lock, assignment, reset the flag. It says more overhead, 2 locks, plus flag check, plus a conditional branch. In terms of CVE instruction by that interpreter steps. Revise the test, the measurable test, and all that with knowledge that the con 1 and 2 are socket con objects. Actually, not generic objects, but really short assessing socket objects is still just a pointer lookup in Python. Other con So just a pointer look at the underlying second element as you receive something services, but I can tell see something like version 1 is 0.36, but version 2 is still faster because it has fewer locks and no flag check, one clean conditional. Even though the sockets are real socket objects, assignment is still just a reference copy, which is extremely cheap and has negligible cost compared to locking and branching. Even though the sockets are real, so then we would just reassign other con every single time. So that's actually faster. So we just say with other con lock, if client num is equal to 1, other con equals self con 2, else other con equals self con 1. Yeah. So this method is actually faster. So we're gonna stop here and take a little break. So use this method below as it is determined to be faster to just reassign other con every time it is accessed, rather than using the other lock and bool system. Alright, so even though this would happen over and over and over in a while loop, it would still be faster to reassign it every single time rather than checking to see if it needed to be reassigned every